Hello, Accelerated Math 6-7 students, and welcome to lesson number 8, video number 8. Turning in my composition book to the table of contents. Today's lesson is called From Ratio Tables to Equations Using the Value of a Ratio. Okay, and basically we find that on page 24. Again, the name of the title is From Ratio Tables to Equations Using the Value of a Ratio. So here we go. Again, I want you to remember, put your titles on every page that we go, From Ratio Tables to Equations Using the Value of a Ratio. Goal. Today we are going to learn how to use the value of a ratio to write and solve equations. Okay. This one is pretty fun, but basically it's building on all of the information that we've been learning in the last couple of weeks. So question, how does the value of a ratio change based on the numbers being multiplied? Okay, that's an interesting question. And hopefully you'll be able to figure it out. All right, what are the values of the following ratios? So basically what I want you to do is answer the value. Remember, how do we find the value? You take the independent and write it as a fraction. Just write your ratio itself. This is the relationship. So it says for every 20 boys, there are 16 girls. So what would be the value of that ratio right there? Basically, you're comparing boys to girls, right? For every 20 boys, there are 16 girls. So that's one way we can write that as a ratio. Here's another way we could write that to a ratio. And then the third way we could write that in a ratio is like this. Well, value of the ratio is this. Remember, that was our quick review. So it says for every 20 boys, there are 16 girls. Okay, so that's the value of the ratio on that one. Can it be reduced? The answer is yes, to 5/4. Okay, let's try the next one. For every 5 boys, there are 4 girls. Aha, pretty good. Okay, let's look at the next one. For every 25 boys, there are 20 girls. Okay, can that be simplified? Yes, it can. Okay, for every 10 boys, there are 8 girls. Can that be simplified? Yes, it can. And then the last one, for every 15 boys, there are 12 girls. Can it be simplified? Again, the answer is yes. All right, so what are the values for the following ratios? 5/4, 5/4, 5/4, 5/4, 5/4. Oh, you can't see them. Let me move it up. 5/4, 5/4, 5/4, 5/4, 5/4. Very good. All right, so now we're going to use what we learned last week is the number of boys is blank, the number of girls. What goes on the blank? This is what we just compared. We said for every boys, there are girls. So the number of boys is what? That is correct. You should write 5/4 in there because we just figured that one out. Now, do we need to find the value of each of these if we flip-flop it? Or can we just think about it for a minute? If the number of boys is 5/4 the number of girls, what would the number of girls be? So you're basically just changing your ratio. You're flipping it over. So if we flipped it over and we did girls to boys, then we would have 16 to 20, which is 4/5. We would have 4/5, which is 4/5. We would have 20 to 25, which is 4/5. We would have 8 to 10, which is 4/5. We would have 12 to 15, which is 4/5. So kiddos, what did we just learn? We learned that the number of girls is 4/5 of the number of boys. Okay? Does everybody see that? All right, so again, going from ratio tables to equations using the value of the ratio. So did we figure out the value of the ratio for either way? The answer is yes, we did. So we know it's 5/4 if you're comparing boys to girls, and we know that it's 4/5 if we're comparing girls to boys. Okay, that's really important for you to use. All right, Jorge is mixing a special shade of orange paint. He mixes 1 gallon of red paint with every 3 gallons of yellow paint. Okay, so basically what we're going to do is we're going to make a ratio table of what we just read. So make a ratio table, red and yellow. So we know blank to 3, 2 to blank, blank to 9, blank to 12, 5 to blank, and then red to yellow. Okay, so let's go back. It says, Jorge is mixing a special shade of orange paint. He mixed 1 gallon of red paint with every 3 gallons of yellow paint. So what has to go in that table right there? You're correct if you said 1, because it says for every 1 red, there are 3 yellow. Okay, so if I was given 2, which I was, so I have 2 reds, how many yellows am I going to have? Correct, 6. If I have 3 yellows, then how many reds was I given? 3, right? If I had 12 yellows, then how many reds did I have? 4. Do you notice a pattern? Good. So 5, what would 5 be? So you will notice every time we go, what are we increasing by? So this from here to here is a plus 3. From here to here is a plus 3. From here to here is a plus 3. From here to here is a plus 1. So this is additive, plus 1, additive, plus 1, additive, plus 1. So what am I going to do here, everybody? I'm going to add 3. So 12 plus 3 is 15. So we know the rule that states for every 1 red, we have what, everybody? 3 yellow. Okay? Does that make sense? All right, so that is how you're going to fill in that table. Okay? But the thing we want to find is we want to find out the value of the ratio. So notice we have the same table, we just added one more column. And that one more column that we're adding on there is a place for us to write down the value of the ratio, okay? Because relationship is the value of the ratio. So I'm going to do mine right here so that I can show my work. So again, this was red, this is yellow, this is relationship. And so basically, I'm just going to look at the table we just made, which mine is up here. So I'm going to look at it. So for every 1, there is 3. The value of that ratio would be what, everybody? For every 1 red, there are 3 yellows, so 1/3. And then if we were to write that out, we would say red paint is 1/3 of yellow paint. Kiddos, do you understand why we wrote it like that? Because we're comparing the red, and you can't see, so let me move this up. Okay, so now let's do it again. This is 2 to 6, so what would the relationship be? 2/6, which simplifies to 1/3. Then we would have 3/9, right, which simplifies to 1/3. Then we'd have 4/12, which simplifies to 1/3. Then we would have 5/15, which simplifies to 1/3. And then we would have 1r to 3y, so I'd have 1/3 r compared to y, so it's 1/3 of every r compared to the y, and that's how we came to red paint is 1/3 of yellow paint. Okay? Boys and girls, how are you feeling about that? Okay? We know that red, let's go back to over here, writing this, we know that red equals 1/3 of yellow. That's how you would write that. Okay? Does everybody understand what we just did? So basically, we took our ratio table and we just turned it into the equation by using the value of the ratio, because we learned that the value of the ratio was 1/3 for it being red compared to yellow. What if we did another one where we did the opposite and we said yellow to red and the relationship? Okay, what if we did this? So we have it's 3 to 1, 6 to 2, 9 to 3, 4 to 12, 5. Oh, no. That's not 4 to 12. Slow down, Mrs. Nelson. You're going too fast. Oh, it would be 12 to 4. Thank you, Mrs. Nelson. Get it right. 15 to 5. And then we're comparing the yellows. So every 3 yellows, there is 1 red. And now let's do the relationship for these. Okay? So basically, we're saying that it is 3 to 1, 6 to 2, 9 to 3, 12 to 4, 15 to 5, and then we're saying for 3 to 1 for it being yellow. So it would be y, yellow this time, equals 3 to 1 of red. Okay, so our relationship would be yellow paint is 3 times, or just 3 parts of red paint. Okay, and so these can all be simplified to 3 to 1, 3 to 1, 3 to 1, 3 to 1, and 3 to 1 is already there, paint. So basically you just, okay, and that is the ratio relationship that we see right there, okay? So basically, moving on, red paint is, what did we decide? Red paint is 1/3 of yellow paint, and yellow paint is 3/1 of the red paint, or 3 times the red paint, okay? And then basically what you need to know, and I kind of showed you that with the pencil, the relationship is the value of the ratio, okay? So now what we're going to do is we're going to make an equation from this information. And making the equation, what you have to do is remember that an equation is an expression with an equal sign. So we're going to pick R. Let's see if you remember it without looking at what I just did. We're looking at R. What did we say the relationship of red was? Red paint equals what, kiddos? What does red paint equal? Red paint equals 1/3 of yellow paint. So that's how you would write it. Red paint equals 1/3 of yellow paint. Okay? The yellow paint equals, what does yellow paint equal, everybody? 3 times the red paint. Okay? And you just made an equation, okay? And we can use this equation for anything. So let's say up here we only went to 5 for red, okay? What if we knew that y in this one was 24? So instead of having 1/3 of y, we did 1/3 of 24. Boys and girls, what is 1/3 of 24? If you said 8, you are correct. So we just learned that when you have 24 yellow gallons, you need to have 8 gallons of red. Do you see how we could do that in our head? That's mental math. Let's try one down here. What if we had 9 gallons of red paint? 9 gallons of red paint. So what are we doing? We're multiplying. So what is 3 times 9? Everybody? That's correct, 27. So when you have 9 gallons of red paint, you need to have 27 gallons of yellow paint. Okay? So that's how we do it, going from ratio tables to equations using the value of a ratio. And that's what we just learned from today's lesson. Okay, go back to your question really quick. How does the value of the ratio change based on the numbers being multiplied? Does it change? The answer is no. The value of the ratio does not change, okay? If it's a true value of a ratio, the value of the ratio does not change. What does change is the ratios themselves, and that's what makes them equivalent ratios. So the value of the ratio does not change, right? Just the ratios themselves, and they become equivalent. Okay, I hope you guys enjoyed the lesson today, and I will see you tomorrow.